Hi, in this lab we're gonna measuring characteristics of BJT transistors. We will automate the process of measurement through LabVIEW again. And first step, we need to build a circuit. For doing so, I will show you in detail how to build this circuit. First, you need BJT transistor TIP31C. If you Google about the pin out of this transistor, it's gonna be like this. This, from the left, the first pin gonna be this pin, gonna be base. The second one gonna be collector, and the second one gonna be emitter. The third one gonna be emitter. This one is emitter. This one, the middle one is collector, and the first one is base. So then we need to connect the base to 33 kilo ohm transistor. I put the transistor here in the base, the breadboard, and then we need to put 100 ohm resistor, which is this resistor, to the collector. Here it is. Collector. That's all, these three components. Then we need to connect our circuit to the power supply. Now as you can see, we should connect power supply to our circuit. Actually, we want to biasing the base and collector and then putting the multimeter in the circuit somehow that we can measure the current pass through the emitter and the voltage drop across the collector and emitter. So we're gonna have the VI characteristic of this. Here, this is the channel 1 of our power supply. The channel 1 of our power supply goes to biasing the base. The channel 2 of our power supply, as you can see, gonna go to biasing the collector, and here is this 2 will measuring the voltage drop across the collector and emitter, and this will measure the current pass through the emitter. The current pass through, and this will measure the current pass through the collector. This too. So referring to the diagram schematic that's shown on lab manual, we will connect these elements to our circuit. So as you can see here I will start to connect the power supply to my circuit. Here is the channel 1. It goes to the channel 1 from power supply. It goes to connect to bias. It's going to go to base, to biasing the base. This is the common ground, which we will use it later on. And this one goes to bias the collector. Then we should put the emitter in the series in our circuit. So for doing so, we should break the connection from the resistor, from the resistor, 100 ohm resistor, and connect it to a meter. Then, and the negative side of ammeter goes to then positive of voltmeter goes to ammeter. This one to the ground. So again, here is 33 kilo ohm resistor. Here is my transistor. Here is how I biasing the emitter, which is it goes all ground goes here, plus the positive of my voltmeter side of my multimeter. And here is how I bias the how I bias the collector. As you can see, here is 100 ohm resistor. It goes to power supply, and this side goes to positive side, and this side goes to positive side of my multimeter. As again I show you, here is voltmeter, here is current meter. Here is voltmeter, here is current meter. This one goes to 100 ohms, as you can see in diagram. Now we're gonna build our circuit. We're gonna build the VI for this lab, so it can automating the measurement. So the next step is the building of VI. For doing so, we open LabVIEW, and the first thing we need to build the front panel. The first step of building the front panel is to building the graph, XY graph. For adding XY graph, it is very easy, as I mentioned in previous experiments. You just go to indicator, select the XY graph as it's shown here, and then you just define the horizontal and vertical. The horizontal is the voltage between collector and emitter, and the vertical is just the current. Then we add the two field for our devices. The first device is the power supply, so we go to VI resource from the front panel, as you can see here, and we add two input field, one for power supply, another one for multimeter. As you can see, after we turn on the devices, you can see two devices, one with DM, which indicates the multimeter, another one DP, which indicates the power supply. Then we have these two inputs in front panel, so by selecting them, your LabVIEW device will figure out that it should connect to multimeter and power supply, and so through your program you can control these two devices. Now we build the block diagram for our VI. So referring to the lab manual, as you can see, the first part is to initiating two devices. as I mentioned before in the lecture, you need, after you making the input, the VI resource name, you need to initiate each device. For initiating the device, you go to instrumental to go to the device, as you can see here in Visa under section called Visa. Then you can go, you can see the Rigol device in last row. So you go to power supply, which is, and again it indicates with DP, mark with DP, power supply, and there you pick the initiate block. So then you connect your device to initiate block. Again, same thing for multimeter. You go to instrument IO, input output, the first row, instrument device, and you go to Rigol. This time you go to multimeter, and again you initiate your device as it has been shown here. So after this, you want to determine the channel of power supply that you want to use and the channels of multimeter that you want to use to measure. So each number, as I mentioned in experiment 6, each number of these represent the channel that you want to use from multimeter or power supply. So let's say for power supply, now we want to use the channel 1, which is represented by number 0, as I mentioned in experiment 6. So number 0 represents the power, the channel of power supply that you want to use. And for multimeter, you want to measure the current and the voltage through the multimeter device. So after determining these two numbers based on our desired channel, we go to build the loop that we need to sweep the voltage for different base current. We want to measure the voltage drop across the collector emitter and current pass through the collector. So first we need to do it for, let's say in this experiment, we need to do it for 3 different. For doing so, we go to, again, programming, numeric or structure, and we define the for loop. So the number of loop here, n, big N, is 3, which means we want to go over 3 different currents that pass through the base. So here is the loop. Now inside this loop, within the loop, we need to have 3 different sequences. In first sequence, we set the current that passed through the base. So then we have 3 different sequences. In first sequence, we set the current passed through the base. Then we set, then in second sequence, we measure, we change the voltage that drop across the current collector and emitter, and then we can measure the current that passed through the emitter. So this is 3 different sequences. Again, for constructing the sequence, we go to programming, structure, as you can see here, and we pick the sequence. So based on that, you can see here, you need to have also in front panel, you need to have the value which represent the resistance in the base, which is 33 kilo ohm. in the first sequence, as I mentioned, we set the current that passed through the base. For measuring the current that passed through the base, we use the formula. As you can see, we assume the voltage drop across base and emitter 0.7. PN junction, voltage drop across the PN junction approximately is 0.68, or let's say 0.7. Based on that formula, we set our desired current that we want to pass through the base. Now we set the voltage based on the formula in the lab that I mentioned in lab manual. We set the current pass through the base. So here I explain how to set this current. So you need to start from 50 microamp. In each iteration you increase your current by 50 microamp. Then you need to set the waiting time for let's say few seconds. After setting the waiting times for the first frame, then you go and pass this value to the next frame. Then you want to pass this value to the power supply. Then you measure the current that passed through the collector. So as you can see here again, we go to instrument input output on the menu by right click, then go to power supply, initializing your power supply, and then drag and drop the power supply setup. You use the first channel of your power supply. In next frame you need to sweep the voltage across the collector and emitter. So in this frame we need loop inside the third frame, and again frame inside that loop. So it's kind of nested loop and nested frame inside the frame. It's good practice for learning about how to make a nested loop and nested frame. So we add another frame, as you can see, frame after the second frame. In this frame, as I mentioned, again you want to initialize and specify the step size of voltage that's applied by channel 2 of power supply across the collector and emitter, and then pass this voltage to the next frame, and then measure the current that passed through the collector and plot it versus the voltage drop across collector and emitter, which is our goal for this lab. So again, I defined for loop. I want to sweep voltage from 0 volt across collector and emitter, and then I want to set the voltage and set the step size. In each iteration I increase the voltage, let's say by 2 volt, 3 volt, whatever you want based on a lab manual. Then after that, inside that for loop, in each iteration again I have first frame, which is I specify the voltage that is provided by power supply. Then I pass it through power supply. Then I measure the current passed through the collector based on that voltage. Then, as you can see here, in this frame we specify the step size of voltage 3 volt. In each iteration we pass it to the power supply. Then from power supply, in third sequence or third frame, we measure the current passed through the collector, and that's how we write our code. As you can see here, after we ran our code, we got 3 different curves of family of VI characteristics for BJT transistor, as we expected. So very briefly, we set the current, the IB, we biased the base of BJT transistor, we turn it on for 3 different values of current that pass through the base. Then we sweep the voltage drop across the collector and emitter, and we measured the current that passed through the collector, and we plot the current passed through the collector versus the voltage drop across collector and emitter, and we got 3 different curves for VI characteristic of BJT transistor for 3 different currents passed through the base of BJT transistor.